Hello, and thank you for tuning in to my presentation about fruit and vegetable consumption in America. I am Nadine Mumford, an MPH student at Purdue University. I researched some of the most updated recommendations for fruit and vegetable consumption, and then looked at recent studies in order to get an understanding of how often Americans were hitting that recommendation. Then I ran a logistic regression analysis on fruit and vegetable consumption and a handful of potential predictors from the 2014 dataset that I had. Before I get into the statistical analysis I completed, I wanted to discuss why fruit and vegetable consumption is so important. Fruits and vegetables are rich in dietary fiber, vitamins, minerals, electrolytes, phytochemicals, and antioxidants. All of these nutrients work toward a healthy digestive system and allow our body the time it needs to absorb the nutrients the body needs to take in. A high intake of fruit and vegetables has been linked to significantly lower risks of chronic diseases like cardiovascular disease, high blood pressure, osteoporosis, several cancers, chronic pulmonary diseases, respiratory issues, mental health problems, and obesity. In particular, a significant relationship has been observed between low vegetable intake and the prevalence of high BMIs. The phytochemicals humans get from fruits and vegetables has been proven to act as an anti-obesity agent as they suppress the growth of adipose tissue, particularly in women. Of course, because fruit and vegetables are so low in energy, they are also conducive for weight loss, which helps in the reduction of obesity. What I found particularly interesting, though, is that first world countries are the ones struggling the most with fruit and vegetable intake. Countries of particularly high esteem are only getting about half the recommended intake. WHO and My Plate guidelines suggest 5 servings of fruits and vegetables a day, and Americans are only averaging about 2.7. I also took a look at a study called Project EAT, which is a 15-year longitudinal study that looked at the eating habits and physical activity of teens and adults. It was really looking at how the eating habits of kids and adolescents in their teenage years carry those habits into adulthood. On the previous slide, I mentioned how drastic the recommendations differed from what people were actually eating. This study offers a closer look at the adherence to My Plate guidelines. The statistics were stratified based on gender and age, since guidelines differ some between gender and age. There was a strikingly low prevalence of people meeting dietary guidelines. As people aged into their 30s and 40s, they were more likely to eat closer to the dietary guidelines. The numbers, even in the 30s, are strikingly low, though, with less than 20% of women in the third decade of life eating recommended levels of fruits and veggies, and less than 8% of men over 30 meeting recommended fruits and vegetable intake. Adolescents had the highest prevalence of eating recommended fruit and vegetable intake, with 36.5% of female adolescents and 29.7% male adolescents meeting the My Plate fruit and vegetable recommendations. However, when researchers eliminated fruit juice, which is packed full of sugar and chemicals that whole fruits and vegetables do not have, this number drops down to 11.9% of adolescent females and only 7.6% of male adolescents reaching the recommended fruit and vegetable intake. Socioeconomic status was found to be a confounder in this study, with 14.7% of the sample being low income, 17.1% being low to middle, 26.7% being middle, and 25.9% being upper middle class, and the 15.6% being high income. This was a variable I also looked at in my statistical analysis of a different data set. After doing this research on the lacking fruit and vegetable intake across America, I developed some research questions. The first one is race associated with the number of fruits and vegetables consumed in a day. My hypothesis was that yes, there would indeed be a statistically significant association between race and fruits and vegetables consumed in a day. The null hypothesis in this case would be that there is no association between race and fruit and vegetable intake. My second research question is perceived access financially to fresh fruits and vegetables associated with the number of fruits and vegetables consumed in a day? The hypothesis for this question was that perceived financial access to fresh fruit and vegetables is associated with the number of fruits and vegetables consumed in a day. The null, of course, would be that there is no relationship between the predictor variable, the perceived financial access to fruit and vegetables, and the outcome variable, fruit and vegetables consumed. The third research question is income associated with the average number of fruits and vegetables consumed in a day? My final hypothesis here was that there is an association between income and the number of fruits and vegetables consumed. The null hypothesis would be that there is no significant relationship between the income and fruit and vegetable consumption. The outcome variable, or the dependent variable, of my analysis was fruit and vegetable consumption. The data ranged from 0 fruits and vegetables a day to 10 fruits and vegetables per day, with some people who either refused to respond to the question or did not know how many fruits and vegetables they ate in a day. I essentially changed these numbers into a dummy variable and defined healthy fruit and vegetable intake as 5 servings or more of fruits and vegetables per the MyPlate guidelines, and then anything less than 5 servings of fruits and vegetables a day was considered an unhealthy fruit and vegetable intake. Because I transformed my outcome variables into dictamous, meaning it only has 2 options, and categorical, meaning that the options are not numerical, so my outcome variables were dictamous and categorical, I chose to do a logistic regression analysis. This test measures the relationship between categorical variables and can test the significance of several predictor variables in the same test. The independent variables I tested for were race, income, and perceived access to fruit and vegetables. I was able to exclude all missing data or refused data from the data set for the analysis. After running an initial analysis, I found that other race, non-white and non-black, had a sample size that was too small for the analysis to work with. So I wound up excluding that data from anyone who did not define themselves as black or white on the race question. This left me with a sample size of 846. All the data was pulled from a 2014 survey that interviewed Hispanics, white non-Hispanics, and black non-Hispanics about the status of their health, fruits and vegetable consumption, sugary beverage consumption, health care, chronic conditions, opinions on the Affordable Health Care Act, and physical activity. Before I get into the regression results, I want to go over some of the demographics of this sample and discuss the variables included in my research. Fruit and vegetable consumption was even lower in this sample than we saw in some of the previous research. Only 10.5% of the sample were consuming recommended 5 fruit and vegetable servings a day. The graphs I have included in this slide display the way I transformed my somewhat continuous numerical outcome variable into a dictamous categorical variable for my analysis. I transformed my other variables in a similar way. Household income was divided into several categories with $10,000 to $15,000 income bumps per year into the different categories. I reduced this entire category into 3 different dictamous variables or dummy variables. I used an under 50K a year category, between over 50K and under 100K a year, and over 100K a year as my 3 categories. Before completing this transformation of the variable, nearly a quarter, 22% of the participants in this study, were making less than $15,000 a year. So we know income is lower than probably the national average in this sample. Perceived fruit and vegetable access is essentially the way participants answered during the past 12 months, has the cost of fresh fruits and vegetables ever prevented you from purchasing them? I was surprised that less than 1/3 of participants noted cost of fruits and vegetables as a reason. Sometimes I even have a tough time justifying the high cost of fruits and vegetables, despite the fact that I typically prioritize produce and fruit and vegetable consumption. So I was surprised to see a sample that is skewed toward lower incomes to note it as an issue in only 30.8 of cases. As I mentioned, I tried to split race into 3 different demi-variables: white, African American, and other. However, 38.9% of my sample identified as African American and 57.2% identified as white. This leaves less than 4% of our sample in the other category. Because the sample size for other was so small, I was forced to exclude that group from my analysis. In order to get a better understanding of the sample, I also looked at gender and household size. 53.9% of the sample was female and 46.1% were male, so slightly more females in this sample. However, a fairly even split. Household size ranged from one-person households to over 8-person households. I split the sample into 3 dummy variables, which included small, which I considered 3 people or less in the household. Medium was identified in my analysis as 4.6 people in the household, and large was considered 7 or more, or living in the same household. The vast majority of participants, 67.9% to be exact, lived in a small household with 3 people or less. And now for the exciting part, logistic regression results. After running the analysis in SPSS, I found sufficient evidence to reject the null and accept my hypothesis that income and gender are significant predictors of healthy fruit and vegetable consumption. While those earning 50K or more did not have significant predictor results after this analysis, those making less than 50K did. The odds ratio was measured at 0.034. When we subtracted that from 1, we got 0.66, which indicates that there is a 66% increased chance of consuming less than the 5 recommended daily servings of fruits and vegetables when one's household income is less than 50K a year compared to those who make more. This is a statistically significant result because the p-value is 0.001, which is well below 0.05. So I can be more than 95% confident that a household income of under 50K is a significant predictor of fruit and vegetable consumption. When we look at the p-values of the other income brackets measured, we can see that they are all much larger than 0.05. 50 to 100K has a p-value of 0.54, and household earnings over 100K has a p-value of 0.97. So the odds ratio of these particular variables are not significant. While our research questions did not include gender, I included this variable in the analysis, more so for confounding tests, which we will get into shortly, but the evidence suggests that gender, as being a significant predictor in fruit and vegetable consumption, which is in line with some of the previous research I had done. There is an odds ratio of 0.47, which means that women are 53% more likely than men to consume at least the recommended 5 daily servings of fruits and vegetables. We can see the p-value is 0.003, again well below the 0.05 required for statistical significance. There was not statistically significant evidence to reject the null hypothesis in regard to race being a predictor of fruit and vegetable consumption or perceived access to fruit and vegetables being a predictor of consumption. We can see the p-values in each of these variables is far greater than 0.05, so we cannot consider them significant predictors and will have to accept the null hypothesis in these cases. This is the output table for the logistic regression analysis. I just went over the numbers and results with you, but this allows you to really see the numbers for yourself. I have highlighted the significant variables we discussed in yellow, and as you can see, no other variables have significant relationships with our outcome variable. You can see that in the SIG column, which is measuring the p-value. There are not any values under 0.05, so with 95% confidence, I can rule those other variables out as significant predictors. I will get into confounding and my discussion results in the next video.